Ja, meine Damen und Herren, auch die letzten zwei Präsentationen, nämlich über die Royal Arena und nun the Design and Application of Velux Modular Skylights, ist es wert, noch zweimal 20 Minuten zu investieren. Es gibt wohl nur ganz wenige Architekten, die über Jahrzehnte die Architekturszene ihres Landes so nachhaltig beeinflusst und geprägt haben wie Lord Norman Foster of Thames. His company Foster & Partners has pioneered a sustainable approach to architecture through a strikingly wide range of work, from urban master plans, public infrastructure, airports, civic and cultural buildings, offices and workplaces, to private houses and product design. And this is our key work today, product design. The development of the Velux modular skylight system was carried out in cooperation by Velux and Foster & Partners. It combined the expertise and experience of Velux for robust and versatile roof light systems with Foster & Partners' industrial design skills and international architectural experience of daylight design for large commercial and cultural projects. The project team consisted of the Velux X-Lab product development team and Foster & Partners construction and industrial design teams, who worked together over a period of 4 years from concept to prototype completion. A warm welcome to Paul Kalkhoven. He is head of technical design and since 2007 leader of Foster & Partners Construction Review Group. Mr. Kalkhoven, the floor is yours.
Good afternoon. I'm pleased to give you today a brief introduction of the design and the development of the modular skylight that we developed with Velux. And I'm joined by Brent Møller from Velux Denmark, who we worked closely together on this whole product, and he will join the dialogue afterwards if I can manage to finish in good time. And so really, where we're getting to, obviously, it was a lovely question to get. Velux obviously very well known for having a great experience over many years of roof lights, but mainly for residential projects. And they came and wanted to work with us to look at roof lights and skylights for non-residential projects. And that obviously is quite a wide range of buildings. And these are some of the selections of projects that we've done in the past with roof lights, and obviously daylight coming from above can do magical things in buildings. It is also slightly scary because if it leaks, you got yourself a big problem. There are all sorts of aspects that we thought it would be great to make a product that actually answers a lot of these questions, not just for us, but for everybody who wants to buy it. And I think it is that sort of aspect of it which makes it not a traditional designed product standalone. It is obviously embedded in whatever building it sits and wherever building it features. Now, the working together, obviously it was 4 years, and it started with you could say a relatively simple brief to say what is best for commercial roof lights. And actually, the more you think about it, there are quite a lot of differences, which I'll take you through in a minute. But it is obviously, it went through dialogue, formulating the brief, going from sketch to model, and then later obviously moved to the Velux factories and testing facilities to look at prototypes, etc. It also involved discussions with other architects to make sure that we are not just making something just to suit ourselves, but also importantly with contractors, people build it to make sure that we understand what they're looking for. And ultimately it's also clients, the end users of buildings, who need to have to live with it and need to look after it for a long time. So it had to do a lot together, but there we go. We're starting with concept and performance. And basically, what are the criteria for non-residential use? a lot of these buildings are bigger than your normal residential building, so we're looking basically for bigger units. We wanted to have, not unreasonably, the biggest piece of glass we could have, but also they tend to be further away from you, so it needs to be remote controlled. It had to be, and I think a lot of the Velux catalog is built up from standard units, a multiple of standard units for which you can build bigger pieces. And we're quite familiar with that sort of modular thinking. But also we say in office buildings and non-residential buildings, you don't find too many pitched roofs. You'll start quite often with a flat roof. So we didn't want the roof lights to stick out too much. So we said we need to keep them as flat as we can. But what is important and what is one of the great benefits is obviously if you prefabricate a roof light, that the off-site fabrication will basically guarantee a waterproof product. And if you can install it simply and get the quality of off-site fabrication, then you have a great product. But also the idea of roof lights being part of a building concept, if you like, in an atrium building, daylight will come from above and can light spaces many floors below, but also it obviously allows for natural ventilation and smoke ventilation. So all of those things shouldn't be afterthoughts, they should be part of the product. We wanted to make sure it had a very high thermal performance, so it was the best performing roof light in the market. It's a sustainable contribution to buildings, allowing natural ventilation, minimum solar gain, maximum daylight, and sustainable materials. Obviously, we wanted to look good, but primarily you wanted to look almost minimal, the smallest frames and the quietest installation. This is our elephant house in Copenhagen of some time ago, and you see the picture on the right. The standard roof light, opening roof light, has a lot of motors which stick into the space, and the roof lights have their own little frame within a frame. All of that, we said it would be great if we could just not see it. We still need to have it, but we don't want other people to come along and tape a bit of wiring to a roof light to fit a motor. And it is last but not least also talking about integrated accessories. Daylight is great, but sometimes you just want a bit less of it, so blinds, etc., want to be part of the system and need to fit in. And obviously, that's sort of accessory thinking, because we may all think that sunlight and daylight is great, but there are times when you have too much of it. Instead, that the roof lights create, obviously, with a small proportion of the roof being open, create a daylit environment, but nevertheless direct sun on somebody sitting at a check-in desk can be disturbing. So filtering of daylight, and on the left the Royal Academy roof light, an art environment where you want to have anything between certainly no direct sun on art or adjustable louvers to control the amount of light, is all critical stuff, and we consider that to be part of the problem to be resolved. So the VMS design, basically, when we started to looking at performance and materials, what would this be made of? Obviously, glass, very important, but framing first of all. And the first thing you obviously would say, particularly with Velux's reputation and experience of wood, what are the good things about wood? And you can see here we're comparing three key criteria of the roof light. It's thermal conductivity, its linear expansion, and its tensile strength. And you can see that here. If you compare that with aluminium, which is probably the most commonly used material, you can see that its conductivity is much greater, i.e. timber is a better insulator, and that's why aluminium would introduce a lot of thermal bridging. But it is also much stronger, as you can see in the red figure. But it also moves more and expands more, which creates its own problems. Now, luckily, and out of all that, we said really we want something which has the character, the advantages of wood, but the strength of aluminium and the smaller sizes of it. Because if you did it all in timber, the frames would be very big, so you would block out the light just when you're trying to get as much in as you try to get. And luckily, we came across a Poltroon material, which is a fairly new material, consists essentially of glass fiber. Glass fibers which are pulled through a die are basically fused together with bonded with a glue, and that holds it together. But 80% of that profile is made of glass. And you can see the interesting things that we can have thermal conductivity of that material similar to timber, but we're getting strength which is similar to aluminium. So we're getting the best of both worlds. And obviously it's linear expansion, because on roofs it will get hot and cold quite a lot. As it is made of glass, it effectively moves like glass. So the glass and the frame are moving at the same rate and therefore not work themselves loose, and therefore are less likely to leak. So that was a great breakthrough. And basically in terms of sizing and shaping, you see on the left a picture of the thermal breakthrough, or the thermal section through the profile, and this is a double profile, as obviously the roof units come along as individual framed units which are put together. We try to make the framing as narrow as possible, so that when you see from below it is as narrow as possible. It tapers up. It's fairly shallow, but you can see that its thermal performance is excellent. It doesn't need additional thermal breaks. It is a very good insulating material. We made it strong enough to carry triple glazing, because in the coldest climates that is what you need to get a good performing roof light. And you can also see in the model on the right that the opening part of the frame is part of the perhaps I can. You can see this is the opening part of the sash. So basically, whether the roof light is fixed, a fixed piece of glazing, or an openable piece of glazing, it will look the same from below. And that was one of the criteria, because when you have a lot of roof lights, you don't want suddenly to see the one which has the smoke extraction unit or the natural ventilation unit to be a frame within a frame and stand out. So now we've achieved basically a very calm appearance with a lot of flexibility that people can tune for various applications. The next we looked at interfaces. We've got to think this can be put on a concrete roof, it can be put on a steel roof. We've got to make it as simple as possible so that the Velux unit sits on top, and basically the builder builds a simple concrete roof with an upstand, and everything on top of that is done by Velux. Not just the skylight, but also the flashings around it. And that is well insulated to make sure as most of the heat losses come through the joints and the flashing. And then the roofer can do his insulation, his waterproofing almost independently, either before or after, and it's quickly built. And underneath the roof light, we obviously have a zone where we can add blinds and other accessories as they come along. Interfaces of waterproofing membranes and vapor barriers are well considered to think how we make the interface of working different trades on site very important for contractors, as simple as possible, and also how they can get it installed very quickly. If you want to try to get a building watertight as a contractor, you want to do it quickly. The beauty of the concealed motor is basically that the motor is sitting in the frame, is accessible from the top, but is invisible from inside. So again, the best of both worlds. Obviously a pretty strong motor to deal with sheets of glass up to 1 meter wide, 2.6 meters long, quite a weight, and obviously has to withstand wind forces, etc. Now, the great thing with Velux is obviously not just their experience, but also they can test it in the most extreme climates. We were talking about the European market, so between the north of Scandinavia and the south of Europe, there's quite a range of thermal conditions, and we had to make sure that all of those extremes were addressed in it, and obviously most importantly waterproofing in all of the possible angles to give people absolute confidence that the unit was watertight. Then a quick look at some built applications. It's been launched progressively over Europe, starting in Scandinavia. And you can see here an atrium solution. So basically, whole strips of repeating roof lights set between structural steel members, which have the gutters, but give an amazing amount of daylight in central atria. You can obviously have the roof light as just strip lights, concealed, semi-concealed, more traditional north lights in educational positions. And finally, just finishing off with a couple of slides to show you a project that's one of our projects, which is currently on site. It is actually a project that is one of the first projects that we started to design and include the Velux skylights into for various reasons. It's taken a long time to get here, but I'm pleased to say it's currently under construction and will open in 2 years' time, will complete next year. But this is the Museum of Roman History in Narbonne in the south of France. Narbonne was a major Roman port, and they have a very big collection of old Roman funerary stones, so basically sort of gravestones, engraved, carved, etc. But they didn't really have a museum for it. It is a competition that we won some time ago, and you can see it's a square building, single story essentially, sitting on the edge of the old city of Narbonne, slightly raised above the ground as it is a flood area. And in section, the roof is a big concrete structure with beams at 15 meter centers, big spans, and the bits outlined in red in the center of the building, which basically separates the public areas from the staff areas at the back. And this is not just museum staff, these are people who are actively restoring and researching the stones, is basically where the roof light, the daylight, forms the most important central accent of the space. And I'll show you a bit more of that. Here we have the walls. It's a rammed earth construction currently on site. And you see the big roof oversailing the walls. Simple solid walls on the outside. And the diagram top right, you can see in green the public areas, in yellow the area where the stones are stored, and above that the staff areas. And this is essentially the key section of the building. On the right you see this racking system. It is an automatic, like you see, a warehousing system where stones can be collected for research, they can be interchanged for exhibition purposes. You can sort of look through it and see the researchers working of it, so it's both a physical separation, but most importantly it's washed from above by the roof light, which you barely see. It's the light that is important. And you can see the roof lights. It's a double pitch configuration, which can open for smoke. It can be opened to perch on the hottest day. It will have blinds to control it, and it's 70 meters long, so a big one. And that is really where we hope to get to next. Thank you.
Come, Brent
Thank
Møller from Velux. I want to go back to this, one of the last pictures. How quick is this modular system implemented on a building? Because normally, if you step a little bit more to the light, thanks. Because I think construction company, and so they, it's time is money. Thank you.
Well, basically, once you've established the ground construction, where you clamp them, as fast as you can lift them onto the roof, you clamp them and you lift the next unit up. So it's as fast as you can bolt them, you can keep stacking them as cards next to each other. Mm-hmm. So it's many times faster. It requires a little bit more preparation, but once you are prepared, you can seal it off in a big atrium in a few days.
Mm-hmm. I got the impression that the science of Velux is to hide things. You hide the shades, you hide the motor, you hide the construction, how to open the window, for example. You hide in this frames, in the really slim frames, all everything, even the motor, etc.
Well-
How small are these things?
Well, the idea of concealing things, or the way it's designed, is inspired by the input by Foster's, of course, with no motors and discrete accessories and so on. The profiles themselves are only 20, 30 millimeters wide, but they're quite high, but that you don't see from below. So we have very slim, high profiles where you can support the glass, the weight of the glass. Yes.
And the motor itself is about this big. It sits.
It's
I think
about
the
this big.
important thing is obviously the light is important, but in skylights, whatever you see against the light is very obvious. The smallest things you will see. So as soon as you push that out beyond the bit of glass, which is what we've done with the motor, it is still there and is actually in the right place for it, but you don't really need to see that. And obviously, this whole thing of just seeing the light, I don't want to see an opening frame, although they all have an opening frame. I don't want to see the motor. And so some may have it, some may not.
I think everybody here knows Norman Foster's cigar building.
Yes, Swiss Re.
Yeah.
Right, the Gherkin.
Gherkin, yeah.
That's where we had.
Nickname, yes.
That's where we had the party, or the introduction of VMS.
launch, yeah.
I called it a party. We had the launch, but that was a fantastic building.
Where are the border of design, where it's not possible to bend glass more than we have seen in the examples? Where is design you can ask for it, but it's not possible to make it true because of the technical components, even if you use glass fiber, for example?
Well, for the glass itself, once you start to make it double curves, it gets quite difficult. We've just introduced a flat roof product which has a curved, where we curve the glass so it can be flat, but the water will run off, instead of these plastic domes. So it is possible to curve glass, but once it's two-dimensional or three-dimensional, then you need a mold, and then it's not really easy to do.
I think there is still an enormous amount of development in glass. Obviously, I think that those are one-off solutions, and I think what we want to do is make something for more mass market, and also price-wise that can be used. Because in that sense, one-off projects you will have, but it is this sort of making good quality roof lights available to a wider market and to have something that performs in terms of sustainability. You don't want to waste your energy through the roof light. And I think, so that was more our emphasis. Perhaps one day we'll do a curved version for them.
I found it's amazing that you're losing less heat through the glass than
through the frames,
through the frames.
Yes.
Is there, and I have learned that you're using a 3D printer to check.
Well, you can
if it
obviously,
is
one can obviously draw, and these computer simulations basically can calculate it, and the colors are like a graph. We can print these graphs in these models, 3D print them with colors, so you will see which bit is the hottest. It is obviously the material properties that you need to put in, and because you know what you're looking for. And I think aluminium has been very successful in cladding and roof lights because it doesn't rust, etc. But it definitely has some drawbacks, and I think this is a new generation of framing materials, which I think is, it's doing great.
So if it's finished, the building, well, it belongs where it is standing, but you have to clean the windows. You have to be careful because if it's in the Emirates, for example, you have the sandstorm. If it's up in the north, there's the load of the snow.
Yes.
So do you certificate your glass windows?
Yes,
where to use it?
We test them, and we have, of course, we need to have to comply with all the different wind loads and snow loads and air tightness and things like that. And that's why the glass is quite heavy for this kind of application, because the force can be enormous on a unit like that. Yes.
Okay.
Thank you. Well, I think obviously cleaning-wise, a lot of commercial buildings have flat roofs, so access is from above. People keep on working down below. It is obviously, I think the glass selection is important, though. I think in the south of Europe, you will need to have a good solar performance glass. So Felix offers a range of glass. In the north, you will need as much light coming through. In the south, you want to keep the sun and heat out. Yeah. And that is a delicate balance, or it varies across Europe. But it's this kit-of-part approach that if you have a range of sizes, a range of fixed and openings, a range of glass, we can effectively have an enormous range of possibilities, which people are exploring by specifying it.
Amazing. Thank you very much.
Thank you.
Brent Møller and
Thank you.
Kalkhoven. Thank you very much.